Okay, let's talk about probability, and let's start with some basic terminology. And the first actually refers to approaches to probability. So in probability, we have the classical approach, the empirical approach, and the subjective approach. In the classical approach, a priori information is given. So when I flip a coin, I know a priori in advance that the probability of getting head or tail is 50-50, or likewise when I roll a die, I know that the probability of rolling a 6 is 1/6. So that's the classical approach. And then we have the empirical approach. In the empirical approach, no a priori information is given. So information needs to be gathered by empirical work. So, for example, in a survey of 100, if I want to know how many students, or what's the probability that a randomly selected student goes to the gym after class or goes swimming after the class, there's nothing that we know a priori. So I would have to conduct a survey, maybe a survey of 100 randomly selected students, and then, depending on the outcome, it might be revealed that 60% use the gym after class or regularly, and then we get an empirical probability for that a randomly selected student goes to the gym regularly. The third approach is the subjective approach, and there is also no a priori information is given, and empirical work is not really possible, and it typically applies to a singular event. So, for example, the outcome of a boxing fight between two first-time opponents. So I would have to introduce subjective assessments of the boxers, and then build a probability for the outcome. So that is a very simple introduction, can be formalized a little bit more, and that enters then the world of what we call Bayesian economics, and we will do an example on this later. But the point here is there are three approaches to probability. There's the classical approach, the empirical approach, and the subjective approach. Okay, but now let's start with some basic terminology. So the first one refers to the mutually exclusive and mutually non-exclusive events. So let's write it like this: mutually non-exclusive events. So mutually exclusive events is like rolling a 1 and a 6 in a single dice roll are mutually exclusive events. So when I roll a die, I cannot roll a 1 and a 6 at the same time. So those are mutually exclusive events. And in terms of a Venn diagram, mutually exclusive events are just illustrated by some events that have no overlap. Then we have mutually non-exclusive events. So rolling an odd number and a number less than 5 are not mutually exclusive events, because I can roll a 1 or a 3, which are both less than 5 and odd. So in terms of a Venn diagram, whenever two events are mutually non-exclusive, there is some overlap. So in this case, we can write here, if you roll a die once, then rolling a 1 and a 6, those are mutually independent. But rolling an odd number, so an odd number would be 5 and 1 and 3. So the 1 and 3 is still part of the yellow bubble or the yellow event of being an odd number, and the blue event, in this case the blue bubble represents numbers less than 5, so we still have here a 2 and a 4, but you see the 1 and 3 belongs to both. Okay, so we have mutually exclusive events and mutually non-exclusive events. Then, next, we also distinguish between independent and dependent events. And somehow that captures the idea of drawing from a bowl. And independent events are drawing with replacement, and dependent events captures the idea of drawing without replacements. So let's do an example. So actually we do examples later, so I'll just before we go into the examples, let's finish the terminology. So we have independent events, dependent events, we have mutually exclusive events, mutually non-exclusive events, and the last important terminology is a complement. And a complement is that a certain event does not occur. So if I want to know what's the probability when I roll a die that it shows a 6, we know that is 1 over 6. Then the complement to rolling a 1 would be not rolling a 1, and that must then be 5 over 6. So the probability of an event plus its complement always needs to sum up to 1. Okay, there's another example. Let's assume there is a bowl that has 10 chocolate squares, 6 dark and 4 milk chocolate squares. In this case, the complementary event to drawing a dark chocolate square is drawing a milk chocolate square, right? So if I want to know, so let's say in this case, we have a bowl or a jar, and we have 6 dark, 1, 2, 3, 4, 5, 6 dark, and 4 milk, 1, 2, 3, 4, then the probability of drawing a dark, P of D, is 0.6, and the probability of not drawing a dark, which is also written as D prime, well, that is equal in this case to the probability of drawing milk, which is 0.4. So the point is the probability of a certain event plus its complement are always 1. Okay, so now we know some basic terminology, and let's stop here and continue in the next video with basic probability rules.